Hello everybody. Today we're going to continue looking at the concepts we'll be encountering throughout the Computer Science 3 unit in Code Combat. Today we're going to be looking at, among other things, properties. So let's begin. You've all used properties before. We've used them to do things like move a hero to a specific position and to check an enemy's type. Properties are specific attributes of objects like hero, enemy, game, that can be used to distinguish them. Now in these levels you're going to see the importance of using properties with the use of flags, which give the game a real-time element. Students place flags on the game screen, have their hero respond to them. Flags are placed after the game is already running, and thus properties must be used to access them, since students cannot predict exactly where they will be placed. So we're going to use level 10 in our Computer Science 3 unit, Backwoods Bombardier. And we're going to take a look. The comment on line 1 says, the POS property is an object with X and Y properties. POS.X is a number representing the horizontal position on the map. POS.Y is a number representing the vertical position on the map. So POS is the object. It's not the property, it's the object. Now what follows that object after a period without parentheses is usually the property. Okay, and properties vary from object to object. Some properties may be common to all objects, like for instance your player objects may have similar properties like speed and health. Position would have really only a property like X or Y for the position on your map. So let's take a look. We see our arrow on line 10. It's asking us to do something. You'll see on line 8, if we back up a little bit, there's a variable called X that's being assigned the position for our enemy. Now the way we access this is we find the nearest enemy, put it into a variable called enemy, and then we're going to look at the variable. So if we find that there is an enemy in there, we're going to access it by first using the object name. Okay, and then we're going to be looking for an object of the object, POS, and then we're going to be looking at the property of that position. So we're kind of doing a hierarchical thing. We're attaching different attributes, okay, using the period, the dot. So we have our enemy variable, we're looking at an object, and then we're looking at the property. Okay, so what it's asking me to do here on line 10 is get the enemy's Y position. So, okay, it's telling me to change this. Okay, so what it wants me to do is change this. So I'm going to just change this. And I'm going to follow the same pattern as line 8. Enemy.pos.x, Y. Okay, and that's going to give me the enemy, the Y position, the vertical position. Okay, it's going to place it into the Y. Then what happens on line 13, the hero is going to say the X and the Y position separated by a comma using concatenation, which we looked at before. Okay, if there is no enemy, the hero is just going to say something else. Just going to say ceasefire, because there's nothing to check. So let's run this program. So you can see the hero is calling out the enemy positions, the X and the Y. Okay, when he finds the enemy. Okay, and you see that the enemy is then vanquished. When there are no enemies, he basically calls out ceasefire, and then they end the program. So just to backtrack again, here properties can also be objects. You'll notice that POS, they call it a property, but it's also an object that can have its own properties. So it could be a little bit confusing, but basically just the thing to keep in mind is you need some information, and you need a way to get to the information. So sometimes it's going to be like peeling an orange or peeling an onion. You're going to have to go through a few layers to get the information you want. So the first thing we need to tell the program is, well, what do I need? Okay, where do I find it? In this case, we're going to first start with enemy, then we're going to be needing to look at the position of the enemy, and finally we want to break it down to either X or Y. And that's what we're going to place into our variables to use in our program later on. Okay. Now the only other thing to remember is the difference between functions and properties. If you see a set of parentheses, in other words, let's look at hero say on line 13. You have hero, which is the object.say. Now, say is a function. You know that right away by you see the set of parentheses following the function name or the method name. Okay, and that is definitely different than a property. Okay, so just keep that in mind as you move forward. The next thing I want to look at are functions with returns. Now we all know what functions are. Functions are the code that we've written ourselves to perform a specific task. Functions are actually not used in our programs unless we call them. We have to actually use the name of the function in order to make them operate. Okay, what I'm looking at today is Burl Bowl Grove, which is level 14 of Computer Science 3. In this level we're going to encounter functions that can compute and return a value rather than just perform an action. So I'm going to take a look at the introduction screen before I start the level. The goals are to defeat the ogres, but don't attack any burrows. So these are these big monstrous things that are, very dangerous. We don't want to attack them because we'll get wiped out. So a function, which you'll remember we code by first using the keyword def, meaning define, which is followed by the function name, and then a set of parentheses. Now normally, we actually have seen this quite a bit. We've seen things inside the parentheses for our functions, but the Code Combat has written those. But again, it's worth remembering or calling out again that in these parentheses, we can trade data. We can actually send data back and forth inside of our programs, from one part of our program to another. If we take a look at the example that they have here on the intro screen, you'll see that we've coded a function called +2, okay, which just contains one single line of code. Okay, you'll notice that inside the parentheses of the function, there's a single variable called x, and the line that's included in the function is return, which we haven't really seen before, and then x divided by 2. Okay, so what actually happens is down below you're going to see the function call right here. Okay, so the name of the function is +2. Outside of our function, we're going to call it by using the name of the function, and then you'll see in the parentheses +2 we're sending some data over. We're sending the number 5. Okay, so what happens here is once we send the number 5 up to +2, x receives 5. It receives the data, which is 5 in this case. Could be any number we want. In this example, it's 5. And what's going on in the function is x is simply, that's not a division, that's a plus, I'm sorry. X, 2 is added to x, okay, here. And then you'll notice this keyword return. What return does is going to just simply return the value immediately, and the flow of control is also returned to the place where the function was called, and then the function stops running. Okay, so let's just, what happens is then the value of +2, which is going to be 7, is then we're then placing it into a new variable called number, which we can presume we're going to use that in our program. So let's just take it again from the beginning. So I have my function called +2. Okay, in my regular code, let's pretend we're in our code outside the function. We're going to call +2, pass it a 5, and then place the return value into a variable called number. So when we call +2 and pass it a 5, 5 is received in the variable x up here. The mathematical function is done. 2 is added to 5, and then the value 7 is returned. Okay, and when it's returned, it's automatically placed into the number variable. So then the value of number is now 7. Let's take a look at the level itself. So what we have here is a function called shouldAttack. Okay, and what they're asking us to do is return false if no target, return false if target type equals burl, otherwise return true. Okay, so we're going to obviously need to fill in this code, but let's take a look down in our main game loop, on the while true loop, so we understand what's going on. Now the first line of code is we're finding the nearest enemy, placing it into a variable called enemy. And then what they're saying here is we should use should attack to decide if we should attack. Hero should attack will be assigned the same value that should attack returns. So we're going to first see if we should attack the enemy, because we don't want to just attack an enemy, because if we do, we may end up inadvertently attacking a burl, which would then result in our hero's death. Okay, so we want to check first before we do anything. We want to make sure that we should attack the enemy. So that's what should attack is going to do. It's going to be sort of like our little check before we do any kind of action. Okay, so the call to the function is actually on line 17. Should attack is then called and being passed whatever was found in enemy. Okay, the return value of should attack is going to be placed into a variable called hero should attack. If that's true, if hero should attack, in other words, if the function returned true, the hero is going to attack the enemy. Okay, so if hero should attack is only going to be true if hero should attack returns the true value. So let's take a look at coding this. So I'm going to go up to my function, just under line 6, the comment, and I'm going to then check to see if there's a target. So if there is no target, and I'm going to use the not, the negation, if not target, we're going to return false, which is simply using the keyword return and then false. Okay, so then the next thing I want to do is I want to check to see if target type is equal to burl. In fact, since they've already written this out, I'm going to simply just copy this code, add parentheses to it. Okay, it says return false if target type equals burl, so I'll do the same thing. Return false, otherwise return true. And as you can see, that's already been written out for us. So just to reiterate, if we're going to check target, if there's nothing there, in other words, the hero didn't find any enemy nearby, it's going to return false. So that means the hero won't attack. If there's a target but the type equals burl, and this is the property of target, if it equals burl, again we're going to return false. Okay, otherwise we're going to return true. That means that there's an enemy, it's not a burl, there is an enemy, and it's okay to attack. So what happens is once the function is done, control gets returned here. Okay, hero should attack will either contain true or false. If it's true, the hero will attack the enemy. If it's false, the hero won't do anything. So let's just run this program and see what happens. Okay, he's attacking the enemies. He's ignoring the burls, which is what we want. So far, so good. So that worked. Now the thing to remember is you can return true false values, you can return numeric values. Okay, so again, a function that we write with the def keyword can accept data, do something with the data, and return the data to where we called the function. Okay, so again, we called should attack down here in our main loop, passed it some data. The should attack function was then executed. It took the data, it evaluated the data, it returned a value, it turned like a Boolean value of false or true, okay, which was then placed into our variable hero should attack. So we made this, we put the assignment operator and followed it by the function call. So whatever the function return is placed in this variable, we check the variable and we attack accordingly.